So in this video, I'm going to discuss the minimum absolute difference between elements with constraint problem which occurred in today's LEETCODE challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the question is very simple. It states that you're given an array and you have to find, and that you're given a constant called x or k, whatever you may call it. So it's x. Okay, so whatever you may call it. So you have to find the minimum possible absolute difference of two elements which are at least x distance from each other. Okay, so for this 4 and this 4 are a distance of 1 2 3, right? 3, that is more than 2, that is at least 2 is satisfying. So what is the minimum possible? It is 0. Okay, for this it should be 1, right? So see, 3 and 2 are a distance of 1, so 3 minus 2 is 1. Okay, for this it is 3, that is only one is possible, that is 1 and 4, because for 2 there is no other position which is at a distance of 3, so only 1 and 4 is possible, and 4 minus 1 is 3, so that is 3. Okay, so this is what basically the problem states. Now let's come to the algorithm portion that we are going to use. So we are going to use a data structure, an advanced data structure. Okay, but I'm not going to reveal what is that advanced data structure, so you have to write it in the comment section, because obviously the video should be interactive, not completely solution based. So you have to write it in the comment section what do you think is the advanced data structure we are using, but I will be giving you the hint of like what we are going to do with it. Okay, so what we can do is, for this 4 3 2 4, so let's take 4 3 2 4. Now check, if we are going to take 4, what are the elements that we can't take? We can't take 3, right? But we can take all the remaining elements. So what we can do is, for all the remaining elements, that is 2 and 4, in this data structure we can store 2 and 4. Okay, remember one thing, that whatever we are storing, you have to sort it. Okay, initially we are going to sort it, right? We have sorted it. Now for 4 we have to check at which position can 4 be inserted using binary search. Okay, so at which position can 4 be inserted? It can be inserted at this position or this position, right? So let's say we are going to insert it at this position. Okay, so since we are going to insert it at this position, so the value can be either 4 minus 4 or 4 minus 2. So which is minimum? 4 minus 4, that is 0. So answer was initially infinity, then answer becomes minimum of infinity comma 4 minus 2, that is 2, and then becomes minimum of 2 comma 4 minus 4, that is 0, right? Now when we go to 3, we can't use 2, right? So we have to delete this 2 and we have to insert 3. Okay, so where can we insert 3? We can insert 3 over here, because 3 is lesser than 4. So since we have inserted this, now sorry, we are not going to insert 3. See, like I just told you, like, okay, so let me do this. Okay, so basically we just delete 2, we are not going to insert anything. Okay, because like for 3, anything twice over here is not present, and anything twice over here is only 4. Okay, so for 3 we can only insert 4, and we have to again check where can we insert 3. So we can insert 3 over here. So 4 minus 3 is 1, so minimum of 0 comma 1 is again 0. Okay, now we are going to do for 2. So for this 2, what we can remove? We have to remove this 4, right? So we remove this 4, but now we have to insert something, that is this 4. Okay, this 4 we are going to insert. So since it is empty, so we can insert a 4 at any position that we feel like. Now we have to check at which position can 2 be inserted. 2 can be inserted over here. So 4 minus 2 is 2. So 0, minimum of 0 and 2 is 0, right? So the answer is 0, because we have already traversed n minus x elements. Okay, so you're going to traverse n minus x elements. So what is it basically? It is going to give you a solution of big O n log n. N is for traversing and log n is for binary search. Okay, binary search in this data structure, like the data structure that you have to tell me in the comment section. Okay, just be a little bit interactive. Okay, so just respond in the comment section what do you think about which data structure I'm going to use for this. So now let me give you a little bit of like more explanation. Okay, so if you check one thing, whenever we are going to consider an element, okay, let's say this is an element. So we have to remove all the x minus 1 element from here and x minus 1 element from here, right? So this is basically a sliding window of size x minus 1 plus x minus 1 plus 1, that is x minus 1 plus x minus 1 plus 1, that is 2x minus 1. Okay, is it clear? So we are going to use a sliding window of size 2x minus 1, and for every position we are going to like delete something and add something, and if it can't be deleted or if it can't be added, so you have to like check for the conditions and similarly do that. Okay, so let me take this example 5 3 2 5 2 10 15 to make it very much clear to you. 10 15. Now see, it is x, for this x is equal to 1, right? So in this data structure, in sorted position for 5, we can use every element, that is, so we can use 2 3 10 15. Remember one thing, I'm sorting it. Okay, so now we are going to check at which position 5 can be inserted. 5 can be inserted at 5 has to be inserted at this position. So the answer was initially infinity. Now it becomes 5 minus 3, that is 2, and 10 minus 5, that is 5. So 5 is not less than 2, so we are not going to change it. Okay, now since we are done with this 5, now we come to this position 3. So what should be the size of the sliding window? It should be 2 into 1 minus 1, that is 1, right? The size of it should be 1. So since we are at this position, so we have to add 5 and remove 3. Okay, clear? So we remove 3 and add 5. At which position we are going to add 5? Check using binary search. So this is the position where we have to add 5, right? So now again check at which position we can insert 3. 3 has to be inserted at this position, right? So 3 minus 2 is 1 and 5 minus 3 is 2. So which is minimum? 1. So what is minimum of 2 and 1? That is 1, right? Now again we have checked this. So now we are going to delete 5 and insert 3 in it, right? I'm extremely sorry, we don't delete 5. Okay, so we delete basically 2 and insert 3 in it. So it is going to be 3 5 10 15, and check at which position 2 can be inserted. 2 has to be inserted at the first position. So 3 minus 2 is 1, right? It gets overwritten as 1. Now again we go to the next position, that is we remove 10 from it and add 2 to it, right? So 2 comes over here. So let me rewrite it freshly. So it is now 2 3 5 15, right? So at which position 10 has to be inserted? 10 has to be inserted at this position. So 10 minus 5 is 5 and 5 15 minus 10 is 5. Both of them are greater than 1, right? So we don't need to think about it. Now we are going to delete 10. Sorry, we are going to delete 15 and add 10, right? So 10 has to be added over here only, and check at which position 15 has to be added. 15 has to be added over here, right? At this position 15 has to be added. So 15 minus 10 is 5, which is also not lesser than 1. So the answer is going to be 1, right? So I hope this is very much clear, like why we are going to do this. So you can do for this also. For this one, the data structure is going to have only 4, and we have to check at which position 1 has to be inserted. 1 has to be inserted over here. So 4 minus 1 is 3. Okay, so answer was initially infinity, then it becomes 3. When we go to 2, we just remove it, we don't add anything. Okay, since it is empty, we have to ignore it. Now when we go to 3, we can't remove or add anything. Okay, again, so it's still empty, so the answer remains it. And when we go to 4, we can add 1 to it. Okay, so add 1 to it and check where 4 has to be inserted. 4 has to be inserted over here, and 4 minus 1 is 3, so it is getting overwritten as 3 only, right? But one thing about this is you don't need to traverse throughout the whole array. You just need to traverse till n minus x, right? So that is 4 minus 3, that is 1. Okay, so just at this position only you can satisfy, like only by traversing till 1, the answer, whatever the answer comes, is going to the final answer. Okay, so the answer is 3, so this is 3. So this is the basic thing behind it. In the comment section, let me know which is the data structure, which is the advanced data structure that you are going to use, and If you still have any doubt, ping me up on Instagram or the Discord server. The both links will be provided in the comment section. That's it from my side. Thank you.